There are some anomalous pictures. It's very much worth humanity's while to travel there and find out for sure, are these artificial or not?
In the realm of space exploration, discoveries often prompt paradigm shifts, altering our understanding of the universe. Graham Hancock, an unconventional scholar known for challenging mainstream history, recently made a startling announcement about a new NASA discovery on Mars. This video explores the details, implications, and reactions to this potentially earth-shattering revelation, giving due weight to Hancock's unique perspective and the broader implications for mankind's place in the cosmos. Graham Hancock, a name known to many, is a British author who has gained fame and notoriety in equal measure due to his provocative interpretations of historical events and civilizations. Born in Edinburgh, Scotland in 1950, Hancock began his career as a journalist before transitioning into the world of alternative history and archaeology. His works, while often controversial among mainstream scholars, have captured the imagination of a substantial global audience. Hancock's books, such as Fingerprints of the Gods and Magicians of the Gods, delve into theories of lost ancient civilizations and the role of celestial events in shaping human history. His theories, while not conventional, often provoke discourse about history's accepted narratives and push boundaries, driving his readers to consider different perspectives. His relevance to the topic of space exploration, specifically in the context of Mars, stems from his interest in ancient civilizations and the mysteries they hold. Hancock is known for his speculative theories that link ancient human civilizations to celestial bodies and events. He has often suggested that our ancestors possessed knowledge far beyond what is generally accepted, hinting at the possibility of connections between Earth and other planets, including Mars. Hancock's keen interest in the stars and ancient civilizations provides a unique lens to examine NASA's recent discovery on Mars. His ability to bring alternative perspectives, challenge established narratives, and draw links between seemingly unrelated events is what makes his announcement about the Martian discovery particularly intriguing. His unconventional approach might yield insights that traditional scientific interpretations could overlook, paving the way for a richer understanding of this extraordinary finding. As we explore this fascinating subject, we will delve deeper into the discovery, Hancock's perspective, and the implications it may hold for our understanding of life in the cosmos. Overview of Mars exploration. Since the dawn of the space age in the mid-20th century, the red planet Mars has captivated our imagination and spurred our exploratory ambitions. Its striking red appearance and relative proximity to Earth make it an enticing target for space exploration. In 1965, NASA's Mariner 4 performed the first successful flyby of Mars, sending back 21 photos of the Martian surface. This mission paved the way for the numerous Mars missions that would follow, conducted by various space agencies from around the world. In the early 1970s, the Mariner 9 orbiter made another significant leap by mapping approximately 85% of Mars's surface. It revealed ancient riverbeds and large canyons, implying that liquid water, a key ingredient for life as we understand it, once existed on Mars. This discovery initiated the search for life on Mars and put forth new questions about its geologic history. In 1976, NASA's Viking landers touched down on Mars, marking the first successful landing. These missions were designed specifically to search for signs of life. The results were inconclusive, but the wealth of data on Martian climate, geology, and the lack of magnetic field provided invaluable insights into Mars's past and present conditions. The 1997 Mars Pathfinder mission and its rover, Sojourner, embarked on the next step of exploration, roving the Martian surface. Mars rovers like Sojourner, Spirit, Opportunity, and Curiosity have since revolutionized our understanding of Mars, revealing evidence of past water activity and organic compounds, both vital for life. NASA's Mars Science Laboratory mission with the Curiosity rover landed in Gale Crater in 2012. Curiosity discovered evidence of an ancient freshwater lake that existed about 3.5 billion years ago, further strengthening the argument for Mars once being a habitable planet. The Perseverance rover, as part of the Mars 2020 mission, and its tiny helicopter companion Ingenuity, are the latest in this line of exploratory missions. Perseverance's objectives are to seek signs of ancient life and collect rock and soil samples for possible return to Earth by a future mission. A significant part of these efforts includes the search for biosignatures, signs of past or present life. The collective findings of these missions have revealed a world that once had conditions suitable for life as we know it. They have painted a picture of Mars's transformation from a warm, wet world to a cold, dry desert, due to the loss of its magnetic field and atmosphere. NASA's long-term goal is to send humans to Mars, an endeavor that requires a thorough understanding of the planet's history, climate, geology, and potential hazards. Each Mars mission takes us a step closer to this goal, providing crucial data to ensure a safe and successful human mission. Furthermore, the possibility of discovering extraterrestrial life, even if it's just microbial, would have profound implications for our understanding of life's prevalence in the universe. The history of Mars exploration is a testament to human curiosity and our quest for knowledge. Each mission builds upon the discoveries and lessons of its predecessors, pushing the boundaries of what we know about our neighboring planet. It's within this context that we examine Graham Hancock's recent announcement about a new discovery on Mars and explore its significance in our ongoing journey to understand the Red Planet and our place in the cosmos. Graham Hancock's announcement. Graham Hancock is no stranger to creating ripples in the academic community, and his recent announcement regarding a NASA discovery on Mars is no exception. Known for his eloquent and engaging presentation style, Hancock disclosed the news during a live broadcast on a popular science podcast. The revelation came as a surprise not only to his avid followers, but also to those in the broader scientific and space exploration communities. Hancock began the announcement by highlighting the long-standing fascination humanity has had with Mars. He discussed the various missions sent to Mars, with a special emphasis on those that have suggested the potential for life on the Red Planet. He mentioned the age-old question that has intrigued scientists and non-scientists alike. Are we alone in the universe? Hancock then revealed the discovery. According to him, NASA had uncovered signs of what might be termed anomalous or artificial structures on Mars's surface. While Hancock refrained from explicitly suggesting that these were made by intelligent life forms, he did stress the abnormality of the findings. He pointed out that these structures were distinctly different from other known geological formations on Mars, and noted that they could indicate the presence of past or even current Martian life. The announcement, much like many of Hancock's previous statements, was met with a mix of intrigue and skepticism. His followers, many of whom appreciate his alternative approach to history and archaeology, were excited by the possibility of life beyond Earth. The idea that Mars may house evidence of extraterrestrial intelligence could potentially validate Hancock's theories of advanced ancient civilizations and their cosmic connections. The wider scientific community, on the other hand, reacted with a degree of caution. Many scientists stressed the importance of thoroughly analyzing the data before drawing any conclusions. They pointed out that extraordinary claims require extraordinary evidence, and while the discovery is indeed intriguing, it must be subjected to rigorous scientific scrutiny. Some even cautioned against the dangers of sensationalism, stating that prematurely linking the structures to extraterrestrial life could fuel unnecessary speculation and misinterpretation. The media, predictably, was abuzz with the news. Reporters and journalists from all corners of the globe covered Hancock's announcement, leading to heated debates and discussions on various platforms. From serious scientific forums to social media networks, the announcement spurred a wave of conjecture and anticipation about the potential implications of the discovery. Hancock's announcement, regardless of its controversial nature, has undeniably captured the world's attention. It has reignited the debate about life on Mars and the possibility of intelligent extraterrestrial life. As we move forward, the careful examination of this discovery, its authenticity, and its implications will undoubtedly be of immense interest to people worldwide. It not only pertains to our understanding of Mars, but also to our broader perception of life's existence beyond the boundaries of Earth. The discovery details. Hancock's announcement outlined that NASA's Perseverance rover, currently on a mission on Mars, made the discovery. The rover, a feat of engineering and a testament to human ingenuity, is equipped with state-of-the-art tools and instruments for studying the Martian surface and atmosphere. Its most essential instrument in this context was the Mastcam-Z, an advanced camera system with the capability to zoom in, create panoramic and stereoscopic images, and assist in the scientific observations of geological features and atmospheric phenomena. The anomalies Hancock referenced were found in a region of Mars that has been of considerable interest to scientists, Jezero Crater. This crater is believed to have been a lake around 3.5 billion years ago, and is thought to hold invaluable clues about the planet's past and the possibility of ancient life. As Perseverance traversed this intriguing landscape, Mastcam-Z captured images of formations that, as Hancock put it, appeared anomalous or artificial. These formations, based on the images released, displayed regular geometrical patterns that distinguished them from the usual rugged, irregular Martian landscape. These patterns raised questions, as they are not typically produced by known geological processes. Moreover, the formations seem to be made from different material or rock types than their surroundings, adding another layer to the mystery. Hancock did not claim these formations to be the definitive work of intelligent extraterrestrials. However, he emphasized their unusual characteristics, hinting that they might not be the result of typical natural processes. From a scientific perspective, the structures indeed warrant a closer look. As we delve into the scientific significance of the discovery, it's crucial to note that Mars has surprised us before. From Face on Mars to Martian canals, the planet has a history of optical illusions and misunderstood geological processes. It is possible that what seems like an artificial structure could be a product of a yet unknown natural phenomenon. Yet, the possibility that these structures could represent remnants of past life, intelligent or otherwise, is exciting. If confirmed, it would be a groundbreaking discovery, marking the first time humanity has found direct evidence of life beyond Earth. Such a revelation would not just redefine our understanding of life's potential in the universe, but also have profound implications for our search for life on other planets. Equally, the finding could lead to a better understanding of Martian geology. Discovering a new natural process capable of creating such formations would add to our knowledge of the planet's geological history, providing further insight into its past climate and possibly its potential for habitability. In any case, the discovery marks a significant milestone in our exploration of Mars. It embodies the unpredictability and excitement of space exploration, reminding us that the universe often holds surprises that challenge our understanding and expectations. As investigations into these peculiar structures proceed, we await what could be a significant turning point in our quest to understand our neighboring planet and our place in the universe. Scientific community's reactions. The scientific community's reaction to Hancock's announcement was an expected blend of intrigue, skepticism, and caution. Scientists across disciplines weighed in on the implications of the discovery and the methodological rigor required to evaluate it. Planetary scientists emphasized that Mars is a geologically complex planet, with diverse geological processes that we are still learning about. They suggested that these structures could be the result of such unknown processes. While they admitted that the formations were unusual, they pointed out the risk of falling into a pattern recognition trap, where humans may perceive familiar shapes or patterns where none exist, a psychological phenomenon known as pareidolia. Astrobiologists were careful not to dismiss the potential significance of the discovery. However, they advocated for rigorous testing and analysis before jumping to conclusions. The search for extraterrestrial life is a delicate scientific endeavor, they emphasized, and any claims must be backed by robust evidence. Meanwhile, space agencies, including NASA, ESA, European Space Agency, and CNSA, China National Space Administration, expressed interest in the discovery. NASA affirmed its commitment to exploring the findings with scientific rigor. They clarified that while the discovery was indeed intriguing, it was still under thorough examination, and any conclusions about its nature and origins were preliminary. Academics and researchers in the field of archaeology and ancient civilizations had varied opinions. Some echoed Hancock's curiosity about the potential connections between ancient human civilizations and Mars, but most insisted on more concrete evidence before drawing any historical or anthropological parallels. Universities and research institutions around the globe followed the development closely. Many were eager to get their hands on the data for independent analysis. The discovery has already sparked numerous debates in scientific forums and inspired several new research projects. The media, always keen on sensational stories, was quick to amplify the announcement. While this brought much attention to the discovery, some scientists expressed concern about the possible misinterpretation and misinformation that could stem from hasty reporting. Overall, the global scientific community's reaction reiterated the value of the scientific method in the face of exciting discoveries. Observe, hypothesize, test, and validate. As further investigations unfold and as more data becomes available for scrutiny, the consensus on the nature of these intriguing Martian structures will likely evolve. Whatever the outcome, the journey promises to be an enlightening one, enriching our understanding of Mars and possibly our place in the cosmos. Hancock's interpretation. As an author and journalist renowned for challenging mainstream historical and archaeological narratives, Graham Hancock has always displayed an alternative and provocative approach to interpreting discoveries. His interpretation of the unusual Martian structures discovered by NASA's Perseverance rover was no exception. In his announcement, Hancock was careful not to make definitive claims about the structure's origins. Instead, he presented an array of possibilities, framed within his unique perspective on ancient civilizations and their potential cosmic connections. He hypothesized that if these structures were indeed the product of intelligent design, they could potentially provide evidence supporting his theories of a lost advanced civilization, or perhaps even a form of ancient or current life on Mars. Hancock has often suggested that human history is far older and more complex than mainstream archaeology accepts. He posits the existence of a technologically advanced yet forgotten civilization that existed millennia ago. He has suggested that this civilization might have had knowledge of or even connections with other planets, including Mars. The discovery of potentially artificial structures on Mars could, he suggested, be evidence of this lost civilization's astronomical knowledge or interplanetary capabilities. Alternatively, Hancock suggested that if the structures are indeed artificial and not a product of human civilization, they could indicate the existence of Martian life, past or present. He reflected on the implications of such a discovery, emphasizing that it could change our understanding of life's uniqueness on Earth, our perspective on the cosmos, and ultimately, our perception of ourselves. Yet, in keeping with his balanced approach, Hancock also acknowledged the possibility that the structures could be natural phenomena, previously unknown to science. Even in this scenario, he pointed out, the discovery could offer valuable insights into the geology and environmental history of Mars, providing new perspectives on the planet's capability to support life. In essence, while Hancock's interpretation leaned towards the more extraordinary possibilities, he didn't dismiss the less sensational ones. His views provoked curiosity and invited discourse on broader existential questions, encapsulating his characteristic knack for questioning established narratives and expanding the horizons of understanding. Whether his theories prove to be valid or not, his perspective indeed offers a thought-provoking lens to view this discovery, triggering deeper introspection about our history, our universe, and our place within it. It is this spirit of inquiry and open-mindedness that defines the exploration of the unknown, taking us closer to the truths that we are all striving to uncover. Potential implications. The recent discovery of peculiar structures on Mars, as announced by Graham Hancock, could potentially have far-reaching implications in various domains of space science and beyond. Regardless of the exact nature of these formations, whether natural or artificial, the findings are likely to influence our understanding of Mars, the search for extraterrestrial life, and future interplanetary exploration missions. In the realm of planetary science, the formations present a novel geological puzzle. If they turn out to be natural phenomena, they could represent an entirely new kind of Martian geological process. Unraveling this process could shed light on Mars's climatic and environmental history, enriching our understanding of Martian geology and potentially offering clues about the planet's past habitability. These insights could help refine models used to predict the evolution of other planets, including Earth. If the formations are indeed artificial, the implications would be groundbreaking. The discovery would be the first evidence of extraterrestrial intelligence, a revelation that would fundamentally alter our understanding of life in the universe. Such a realization would have profound implications for astrobiology, the interdisciplinary science that explores the origins, evolution, and distribution of life in the universe. Astrobiologists have long speculated on the existence of life beyond Earth. If Mars once harbored life, or still does, it would suggest that life might be more common in the universe than previously thought. The discovery could stimulate further research into extremophiles, organisms that survive in extreme environments on Earth, and their potential analogs on other planets. It could also invigorate the search for life on other planets and moons in our solar system and beyond, including the icy moons of Jupiter and Saturn and exoplanets orbiting distant stars. Such a revelation would also likely impact philosophical and ethical considerations concerning our place in the universe and our interactions with other life forms. It could stimulate dialogue about space exploration's ethical implications, including planetary protection measures and the potential consequences of contaminating other planets with Earth life. The discovery could influence the future direction of Mars exploration missions as well. Future missions might prioritize locations similar to the Jezero crater, where the formations were found. NASA and other space agencies could design new instruments to specifically investigate these types of structures, leading to technological advancements in planetary rovers and spacecraft. Public interest in space exploration could see a significant surge, potentially leading to increased funding for space programs and inspiring a new generation of scientists, engineers, and astronauts. This discovery, with its mystery and potential, could serve as a reminder of the vast, unexplored frontier that is space and the exciting possibilities it holds. The potential implications of the Martian structures are far-reaching and transformative. They speak to the spirit of human curiosity, exploration, and our relentless pursuit of understanding the universe around us. As the curtains are gradually pulled back, revealing Mars's secrets one layer at a time, we stand at the threshold of potentially revolutionary insights about Mars, life's existence beyond Earth, and perhaps the very nature of the cosmos. As the scientific community prepares to delve deeper into the mystery of these formations, the world watches with bated breath. Whether the formations turn out to be natural or artificial, the discovery promises to add to our collective knowledge and possibly reshape our understanding of life's potential in the universe. Regardless of the outcome, we find ourselves at an exciting juncture in our journey of cosmic exploration, ready to embrace the revelations that lie ahead. Broader repercussions. The impact of the Martian structure's discovery, as unveiled by Graham Hancock, extends well beyond the scientific realm. The broader societal, philosophical, and existential implications of such a discovery have the potential to resonate across humanity, challenging our perceptions, beliefs, and understanding of our place in the universe. From a societal perspective, the discovery could incite renewed interest in space exploration and science in general. It could influence educational curricula, fostering a new generation of young minds keen to explore the mysteries of the universe. Governments might allocate more resources to space exploration, leading to technological advancements with unforeseen applications that could reshape society in various ways. The discovery could also stimulate a resurgence in the global discourse around space laws and policies, prompting countries to establish or update frameworks governing space exploration and potential future colonization. The prospect of life on Mars could also spur conversations around ethical considerations, including the responsibility of preserving other worlds' environments and avoiding any potentially harmful contamination. From a philosophical standpoint, the discovery could stimulate profound introspection about our existence and purpose. It could challenge religious and spiritual beliefs, offering new perspectives on questions around creation, divinity, and the nature of life itself. Philosophers and theologians alike could find fertile ground for discourse in the implications of potential life beyond Earth. If the structures are indeed evidence of extraterrestrial intelligence, we may have to grapple with the notion of being not alone in the universe. This reality could have deep psychological implications, compelling us to reconsider our significance in the cosmic context. Our conceptualization of otherness and the boundaries of our empathy might also be pushed into uncharted territories. Existentially, the discovery could alter our understanding of life as a phenomenon. Life as we know it is based on our singular experience on Earth. But what if life on Mars, past or present, followed a completely different evolutionary path? It could force us to redefine what we consider life and expand our perspective to include forms of existence beyond our current comprehension. The implications become even more profound if we consider the possibility that these structures could be remnants of an advanced civilization. This could lead us to reflect on the impermanence of civilizations, including our own, and the universal challenges that advanced societies might face. It might also provoke reflection on the nature of progress and the potential paths our own civilization could take. Finally, the discovery might fuel the human imagination, inspiring artistic and literary works that explore the themes of life beyond Earth, our cosmic loneliness, and the vast potential of the universe. Artists, writers, filmmakers, and musicians could find in this discovery a source of inspiration, leading to a cultural renaissance infused with a sense of cosmic curiosity.